Hello everybody and welcome back to Advanced Maths. Today we're looking at implicit differentiation. Before we begin, you'll need to know how to differentiate simple expressions, how to find the tangent to a curve, and how to find turning points of a curve. This will mean that you know pretty well how to differentiate all kinds of simple expressions. And you will need to use that in today's video. If you don't already know how to do that, I will leave a link to some videos on this in the description below for you to watch first. But without much further ado, let's look at what does implicit mean. Well, explicit means that the y is on its own on one side, whereas implicit means that x's and y's are on both sides of the equation, and that x's and y's can be multiplied together, and that y doesn't have to be on its own on one side. So you can see some explicit equations on the left and some implicit equations on the right. Example 1, we're going to differentiate this equation. Okay, and there's 4 terms to this equation, and we'll just differentiate them separately to really see what's going on. We'll differentiate 5x to be 5. We'll differentiate minus x squared to be minus 2x. This is how we differentiate normal x expressions. However, the 2y, we'll differentiate that to 2, but then we'll also multiply it by dy over dx. Because here we're differentiating y, and the rule is if you differentiate y, you have to then multiply the answer by dy over dx. So the top 2 we were differentiating with respect to x, that's fine. However, on the bottom we were differentiating with respect to y, and so we have to multiply by dy over dx. The y to the power 5 we differentiate to 5y to the power 4, and it looks like that. But we also multiply by dy over dx as we did before, because that's the rule. So we can put those back in order, so 5, 2y dy dx, and then we've got that one. And you can see here I've colour-coded it so you can see which expressions differentiate to which part. The main takeaway here is that if you differentiate an expression with y in, you then multiply the answer by dy over dx. Now we've done that part, we can rearrange and make dy over dx a subject to the formula. We'll start by moving all the x's to one side and all the y's to the other side. So we've moved minus 2x to the other side by making it positive 2x. And now we've got dy over dx's on the same sides, and that means we can factorise them out. And so we've got this expression here, and then we'll divide by the bracket, and we'll get like this. So we'll get dy over dx is 5 plus 2x over 2 plus 5y to the power 4. And that final step of rearranging the expression to make dy over dx the subject of the formula is really important. And that's the final answer. And we've differentiated it implicitly. Example 2, we're going to differentiate this expression, and this is a bit harder because we have x's and y's multiplied together. And there's a different rule for this. So we'll start by making the x over y, xy to the power minus 1, because it's always better to differentiate things when it's got a negative power instead of a fraction. We'll start by differentiating this term here, and we'll differentiate with respect to x first, and that becomes 24x squared y squared. The 3 comes down to make 8 times 24, 8 times 3, which is 24, and the power of x decreases to be x to the power 2. So we start by just differentiating the x's normally. The y squared stays where it is, that's just something you're multiplying by. Now we'll differentiate the y squared, and the power of 2 comes down, so 8 times 2 is 16, x to the power 3 stays, and the y becomes y to the power 1. Because you take 1 off the power, 2 minus 1 is 1. But we've differentiated with respect to y here, so we need to multiply by dy over dx. So what we've done is we've differentiated with respect to x, and then we've also differentiated with respect to y, and we've added the 2 answers together. And that's the rule, that's how we do this. So we've got a term with x's and y's together, we differentiate for x, differentiate for y, and add them together. Okay, let's look at the next term in the sequence. Well, sorry, I've just colour-coded this, so the green part differentiates the x, the blue part differentiates the y's. Next term, we've got 2x y to the power minus 1. So the 2x, because it's x to the power 1, just the x disappears, and it's 2y to the power minus 1. And then the y to the power minus 1 the power comes down, and it's minus 2 y to the power minus 2 dy over dx. Again, we've multiplied by dy over dx there because we were differentiating with respect to y there. And then the plus 9 disappears. We're going to rearrange and simplify this expression like this, and we times by y squared. Because we've got a divide by y squared here, we need to get rid of that divide by y squared. And we'll get this. We'll rearrange and we'll factorize out the dy over dx, and we'll divide by the new answer, and we get dy over dx equals this expression here, and it's quite messy, but that is the final answer there. Okay, that is the final answer, and we've done. Question 3, this is where we're going to apply it to a real example. So we're going to find an equation for the tangent of the curve xy equals x squared plus 2y at the coordinate 1 minus 1. Okay, so we're going to differentiate this. The xy differentiates to y plus x dy over dx. The x squared differentiates to 2x, and the 2y differentiates to dy over dx. Okay, so that is just differentiated implicitly as we've done before. We're going to rearrange and make dy over dx the subject of the formula. And we'll divide like this. So dy over dx is 2x minus y over x minus 2. We've differentiated now, that's the first step. Our next step is to substitute in the coordinate, which is 1 minus 1. So x is 1, y is minus 1. We substituted that in there. And we can evaluate that using our calculator or just doing it in our heads. And so we get the gradient at this point is minus 3. And so we get the equation of the tangent must be y equals minus 3x plus c. So we've evaluated the derivative in that orange box there. Now we're just going to find the plus c by substituting in the coordinate, which is x equals 1 or y equals minus 1. And that gives the c is 2. And so we've got the equation of the line is y equals minus 3x plus 2. And that is the equation of the tangent, and we've done. Okay, that's everything for today's video. I've shown you 3 different examples of differentiating implicitly. I'd like you to now pause the video and try these questions yourself here. This will take you about 10 minutes, so pause the video now please and try this yourself. When you're ready, I'll reveal the answers in 3, 2, 1. Did you get it correct? Let me know how well you did in the comments below. Thanks for watching this week's video from Addvance Maths. We've got more videos coming every week, so remember to like and subscribe so you don't miss any future videos. We're covering A-level and IB Maths every week, so definitely worth subscribing. Also got advancedmaths.com, which may be helpful for your revision. Thanks for watching and good luck in your exams.